Hi everyone, I want to take you through something very somehow it looks difficult, but it's very quite easy and amazing. I want to take you through quantum mechanics, which is one of the topics or one of the units in university for those students who are taking education science and physics and also engineering. Those people who are doing engineering, they must do quantum mechanics. So I want to take you through. In quantum mechanics we have some topics which are quantum mechanics. We look at classical mechanics, which is an approximation of quantum mechanics. We look at the wave equation, Schrodinger equation, which we have two time dependent form and time independent Schrodinger equations. We will also look at linear and superposition, expectation values, operators, Schrodinger equations in a steady form, and look at particle in a box, finite potential well, tunnel effect, which we also call it tunneling, and harmonic oscillator. At tunneling, it is quite very simple. Now let's start our class by looking at quantum mechanics. We are starting with the failures of quantum mechanics, which will look at the theories which the physicists tried to come up with. First theory, we are going to look at Bohr theory of atom, which say that the Bohr theory of atom has several Bohr theory of an atom. So we are going to look at limitations, which one of them it applies only on hydrogen and one electron ions such as helium and lithium. What does this say? According to Bohr theory, it did not find or experiment on those atoms which have more than one electrons or more than one ion, and also it was not able to explain why certain spectral lines are more intense than others. For example, in hydrogen and helium are so different, they look so much different from one another, but he didn't explain something about it. Also, it cannot account for the observation and the many spectral lines actually consist of several separate lines whose wavelength differ slightly. And then we have, perhaps most important, it does not permit to us to obtain an important understanding of the individual and interaction. In a more general approach to atomic phenomena is required. Then number 2, we are going to look at classical mechanics. We need approximation of quantum physics, which is approximation for quantum physics. Now, the difference between classical mechanics and quantum mechanics is that classical mechanics looks at a microscopic bodies, while the quantum mechanics looks at a microscopic bodies. This is why I'm saying classical mechanics is an approximation of quantum mechanics. The fundamental difference between them I have already said, and then in classical mechanics, maybe to state more further, the further history of a particle is completely marked by its position and momentum. But in quantum, it also arrives by observable quantities, uncertainty principles. Now let's start our class, which now is officially started. We are starting with our wave function. From this, we are going to see what's a wave function of a body and how does wave function relate with a body. The wave function ideally does not have a meaning, but this wave function, the square of wave function, keeps the probability of a body to be somewhere, which now it becomes to be a must positive for a real quantity. Now, linear momentum, angular momentum, and energy of a body quantities that can be established from wave function of a body, which is represented by phi. The problem of quantum mechanics is to determine phi for a body when it's free of motion by action and external forces. So, wave function